Good everyone, my name is Graphics. Now we are told to find the center of gravity of this figure. What we'll do here is this. The figure is sectioned. We look at the section line here that is inclined, and there's a true in between. 25mm is true. So what you do is you can split this figure, right? You can split it into as many parts as possible, but to the lowest possible division. So what you do here is this. If I place a line here, you discover that I'm having a triangle. If I place another line here, discover I'm having a triangle. So let me bring out this triangle out. Now if I bring a triangle out, the top of this, you see 25 on top here. If I subtract from 40, I am going to be having 15. So I'll be having my triangle, the height giving us 40 and the base giving us what? 15mm, which I have here, which you can see, right? I'll call it figure 1. Now if I check the other figure, there is forming a rectangle and the remaining is what? 25mm, as you can see, right? So if I remove it from there, I'll be having this, which will give us what? The height of 40 and the length of what? Of 25. I'll call it my figure 2. Now the true, that is the unsectioned part here, which is 25. Now since it's unsectioned, if I bring it out, right, the length is 25 and the height is also what? 40. That is my figure 3. Now I move again. If you look at this with my line, the 25mm, if I remove it out, I will call it my figure 4. So the height is still 40 and the length is what? Is 25. Now the remaining parts, if I subtract 25 from the 40 I have here, right? If I subtract 25 from the 40 I have here, it will give me 15. So I will be having the base of the triangle to be 15 and the height to be 40. These are the 5 plane figures I have here, right? So I can now say that my formula for this figure, applying the center of gravity formula for this figure along x-axis, given as what? My x bar equals to the summation of ax, that is the area times the distance, all over the summation of the area. And this means that summation means addition of all the area times what? The distance. So I'll be having a1 x1 plus a2 x2. Then now instead of me putting plus, normally I ought to put plus there, but because that a3 you are seeing here is on section, means that what? There's a true, right? They've already cut out that a3 out of the figure. That is a hole in between. You can see what I mean is having a hole in between. So I'll put my minus a3. But assuming they sectioned everything, or they didn't section anything at all, it will be plus a3 x3. But since that figure 3 is sectioned, that I'm putting is on section, right? That means I'm putting what? Minus a3 x3. Now plus a4 x4 plus a5 x5. Is that okay? Now this is what we are having, all divided by area of the first figure plus the area of the second figure plus minus the area of the what? The third figure. So I will always subtract, because of what? That part is on section. It's telling me that what? There's a true there. Now plus the a4 plus the a5. So this is my formula. Now I need to get each of those variables, each of those parameters. So let's start. Now I'll put it this way. A1 will be equals to, now we have A1 here. We'll look for the distance of A1. So if you look at the distance of A1 now, we are going to be having is a triangle, just like you can see at the top corner here. It's what? It's a triangle. So the triangle, the center of gravity of triangle will be the length over what? Over 3, since we are considering along x-axis. So it will be the length over what? Over 3, right? So if I do that, we'll be having 15 all over 3, because the length of the triangle is what? Is 15. So I'm going to divide it by what? By 3. And if we divide 15 by 3, we'll be having 5 millimeter. Similarly, I'll look for what? A1. Now the A1, that means the area of the triangle of that figure, which is a triangle, is half base times height. So if I put it there, my half, the base is 15 times what? The height, which is what? 40, equals to what? We'll be having 300 millimeter square. That is the unit for what? For the area. Now we'll go to the next figure, which is S2. So the distance S2 is that before I get to X2, look at what I'm having here, look at my arrow. I need to travel 15 first before I'll get to what? S2. So it will be the 15 plus the S2 I'm considering, the length of the S2 I'm considering is what? Is 25, right? So, and the center of gravity of a rectangular figure is what? The length of the figure all over 2. Since I'm going along X-axis, so it will be the length all over what? All over 2. So that will be 15 plus 25 over 2. And that's going to give us what? 27.5 millimeter. Is that okay? Now, similarly, the area of a plane figure, of a rectangular figure, is length times breadth. So the length of this figure 2 is given as 25, and the height is given as what? 40. So if I say 25 times 40, I'm going to be having 1000 millimeters squared. That's the area for what? For A2. Now I'll go to the third one, which is distance of the figure 3. And that will give, now before I get to figure 3, look at, I'll first of all get to figure 1 and figure 2 before I get to what? Figure 3. So figure 1 has a distance of 15, plus figure 2 has a distance of 25, plus figure 3 has a distance of 25 also. But because we are considering figure 3, I will say S3, we're going to divide it by 2. Why would we divide it by 2? Because of what? It is a rectangular figure, or if it's a square also. So we divide it by what? By 2. But as means of the triangle, I'll divide it by 3. So I'll divide it by 2 now. And if I do all my calculation, 15 plus 25 plus 25 over 2 give us what? 52.5 millimeter. So that is for the S3. Now, the A3 will be the length of that figure 3 times the breadth. And the length is 25, and the height is what? Is 40, right? So that is, will give us 1000 millimeter square. Now go to the figure 4. So distance of X, figure 4, S4. It will give us, before I get to that S4, I'm going to travel figure 1, figure 2, figure 3 before I get to figure 4. So the distance of figure 1 is 15, plus the distance of figure 2 is 25, plus the distance of figure 3 is 25, right? Plus the distance of what? Figure 4 now is also 25, but since I'm considering figure 4 and it's a rectangular figure, I'm going to divide by what? By 2. So if you add 15 plus 25 plus 25 plus 25 over 2 give us what? 77.5 millimeters. So that's what we have. So I'll calculate for the area. So the area of a rectangular figure there will give us the length times the height, right? So we'll say that the area, that is 25 times what? 40. And that will give us 1000 millimeters square also. Now we'll go to the final figure. Now you can just do that on your own and see if you get that right. You can pause the video and do that. Now, did you get it? So let's see how it goes. So X5 will now give us, for me to get to figure 5, the distance of figure 5 from the starting point is 15 plus 25, that is the second figure, plus 25 plus 25. So before I get to that figure 5, I will travel through figure 1, 2, 3, 4. And that will be 15, 25, 25, 25. Then plus the length of that particular figure I'm considering is 15, right? So since it's a rectangle, a triangle, I'll divide by 3. So it will be what? 15 all over 3. And we'll be having what? 95 millimeter. Now the area of that figure 5 is like, I'll see A5 will be half base times height, right? So it will just be 1 over 2 multiplied by the base is 15 and the height is 40. So we'll still be having 300 millimeters square, right? Is that taken? Now we'll now apply our formula above. So let's start. We say that the x bar, which is the center of gravity along x-axis, will be, if you look at the formula, my a1 is given as what, 300, so I'm going to place 300, multiplied by my x1 is what, is 5, so 300 times 5, that is 1, plus my a2 x2, so a2 is given as what, 1000, times my s2 is given as what, 27.5, that is another part, minus a3 s3, my a3 is 1000, times my s3 is what, 52.5, right? So I'll put it in one side, this is what we have, plus my a4 x4, that will be 1000 times what, 77.5, because a4 is 1000 and x4 is 7.5, so we have this, plus my a5 x5, that will be 300 times what, 95, right? So we have all divided by a1, which is 300, plus a2, which is 1000, minus a3, which is 1000, plus a4, which is 1000, plus a5, which is what, 300. At the end of the day, we'll be having this. So we'll say that my s bar, which is the center of gravity along x-axis, will be equals to 300 times 5 is 1500, plus 1000 times 27.5 is 27500, minus 1000 times 52.5 is 52500, plus 1000 times 77.5 is 7500, plus 300 times 95, and that will give me what, 28,500, all divided by 300 plus 1000 minus 1000 plus 1000 plus 300 will give us 1600. So we will now say that what, my x bar will be equals to what, if you add everything at the numerator there, to give us what, 82,500 divided by 16, and this will give us s bar to be equals to what, 51.56 millimeter. So this is the center of gravity along x-axis. Is that taken? Now, as it is this way, we'll also calculate for the center of gravity along y-axis. So I'll just try the center of gravity along x-axis. S bar is this, somewhere here. So I'll start from center of gravity along y-axis. So everything still sticks. What I'll just change here, for my formula above, right, I'll say that instead of writing x bar now, I'll write what, y bar, because I'm going along y-axis now, vertical. So I'm going along y-axis, so it will give us the summation of ay over what, summation of what, a, and this will be a1 y1 plus a2 y2 plus a3 y3 plus, then instead of me putting a3 y3 to be minus a3 y3, is that taken? Because that part a3 is there's a hole there, so you have already extracted, remove that part of it. So minus a3 y3 plus a4 y4 plus a5 y5, all over a1 plus a2 minus a3 plus a4 plus a5. So this is my new formula here now. Now, since we are considering the same figure, the area will not change. The area will remain the same. So what we just change is this. It will be only the distance, since we are going along y-axis. So instead of x1, I'll be having y1, right? So my y1 will be equals to 40 over 3, because the height I'm going along, my distance now is not along y. So what I'm considering is what, is the y-axis. So instead of using the x, I'm using the y. So it will be y-axis, it will be the height of the figure is 40, so it will be 40 over 3 since the triangle. I'll be having 13.33. The area still remains the same. Y2 will be the figure of 2, the height is still 40, they have the same height, every one of them, they have the same height, so the height is uniform. So my y2 will be 40 over 2 to give us what, 20 millimeter. My y3 will give us 40 over 2 will give us 20 millimeter, still the same thing. My y4 also will be what, 40 over 2 give us what, 20 millimeter. And my y5 is what, 40 over 3, because the triangle, the figure 5 is triangle, so it will be 40 over 3, and that will give us what, 13.33. So this is what we just change. Now we repeat the same thing, apply them into the formula we have above. So my y bar will now be, you multiply each of them. So when you multiply the a1 y1, which is 300 times what, 13.33, plus the A2 Y2, the Y2, the A2 is 1000, the Y2 is 20, minus the A3 Y3, the A3 is 1000, the Y3 is 20, plus A4 Y4, the A4 is 1000, the Y4 is 20, plus A5 Y5, the A5 is 300, and the Y5 is what? Is 13.33, all divided by 300 plus 1000 minus 1000 plus 1000 plus 2. That is A1, A2, A3, and A4. Is that okay? Now, if you do the needful, you do your normal calculation. You say that your Y bar will now be giving us 3999. That is 300 times 13.33 is what? 3999 plus 20,000, because 1000 times 20 will give us 20,000, minus 1000 times 20 will give us another 20,000, plus 20,000 plus 399. So when you use what we have, all divided by 16. Now if you do that, we'll be having 399 plus 20,000 minus 20,000 plus 20,000 plus 399 will give us what? 27,998, all divided by 16. I will be having 17.498 millimeter as the center of gravity along y-axis. So this is how you can calculate the center of gravity of this particular shape we have here. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.